So today we're talking about prime and composite numbers. The title of your page is Prime versus Composite. Like they're opposing sports teams or something. No, really, they're both just kinds of numbers. We're going to start with a defining sentence. Okay, a prime number is a number that has only two factors. Remember, a factor is something that you multiply two factors to get a product. Okay, so a prime number is a number that has only two factors, 1 and itself. Okay, and then because it's a defining sentence, I'm going to go ahead and underline what I've just defined, and what I've defined is prime number. So a prime number is a number that has only two factors, 1 and itself. Okay, and the example of a prime number I'm going to put down here is the number 5. Okay, so think about what we were talking about with those divisibility rules. Okay, 5 is not an even number, so it's not divisible by 2. It ends in a 5, so it's divisible by 5, but it is the number 5. Okay, the number 5, the only way to get 5 is 5 times 1 equals 5. So the number 1 is a factor, and itself is a factor. Okay. So we can also show this with a 1 and a 5, little arch here, okay, showing that 1 times 5 equals 5, okay. So 5 is a prime number, and we're going to talk about some other prime numbers in a minute, but right now we're just getting a definition down, okay. So if a prime number is one that has only two factors, what's a composite number? A composite number, another defining sentence, is a number that has more than two factors. Okay, there's more than two ways to make the number. Okay, so let's do 12. 12's a really nice one. Okay. Okay, so when you think about 12, let's see, you know that 12 times 1 equals 12. Okay, but then think about those divisibility rules. 12 is an even number, so something times 2, 6 times 2, and therefore 2 times 6 equals 12. Okay, the digits 1 and 2 in 12, 1 plus 2 equals 3, so 3 is a factor of 12. Okay, so 4 times 3 equals 12. Okay, and I can write this a couple of ways. I can do that 1 and 12 like I did earlier with the 5. Okay, 1 and 12. But then look, it keeps going. I can also do 2 and 6. Okay, 2 and 6. And then I can also do 3 and 4. And you see how we have this nice little rainbow going. Okay, composite numbers, when we write them out like this, it looks like a rainbow, and not just a sad little frowny face like it did for the prime number. So that is your basic definition versus composite. And because this was my defining statement here, I am going to underline again what I was defining, composite number. Okay. All right. So on the facing page here, I have put a hundreds chart, and I am going to use this hundreds chart to kind of explore a little bit more with prime and composite numbers. First, I'm going to start with the number 1 though, because it's kind of special. Number 1 is neither prime nor composite. Okay, so 2 is actually my first prime number, and I'm going to leave it alone for right now, and I'm going to pick a color, and I'm going to use that color. I'm picking yellow, and what I'm going to do is after the 2, I'm going to look at everything that is a multiple of 2, okay? Because 4 is a composite number because it's divisible by itself, 1 and 2. So every single even number except for the number 2 is a composite number. Just think about that. All the even numbers. And so what I'm going to do is I'm going to go through and I'm going to color in all of the even numbers. Okay? And I can do that by skipping every other one. Okay? But you guys are pretty smart, and I think you're going to notice here pretty quickly that I could just go all the way down, and so that's what I'm going to do. Okay, so obviously you probably need to pause the video and do that coloring yourself pretty quickly. I opted not to videotape myself, coloring in lines of yellow, though I could if you want that for next time. So the only even number that is a prime number is the number 2. And so I can get rid of all of these because they are even numbers. So what's the next most logical number or series of numbers for me to look at? To me, it would be the 5s, okay? This line right here. So of course, the number 5 itself is prime. See? Because its only factors are 5 in itself. But every other multiple of 5 is divisible by 5 and is therefore a composite number. Now, everything that ends in a 0 I've already marked because those are even numbers. But after the 5, I can take, and I'm just opting to do a different color because I'm looking at a different rule, everything that ends in a 5, so I can color this whole line down. Okay, so now I've addressed the 5s, all right? So now I'm going to pick a different color, and now I'm going to think about multiples of 3, okay? So 3, 6 is already colored in because it's an even number, but 9 is a multiple of itself and of 3, okay? And so what we do here, the next multiple of 3, go 1, 2, and then it would be 12, 1, 2, and then 15, 1, 2, 18, 1, 2, 21, okay? 3 times 7, right? 1, 2, 24 is already colored in. 1, 2, 27, 9 times 3. Okay, 30 is already colored in. Okay, 1, 2, 3, 33, 3 times 11. 1, 2, 3, 1, 2, 3. And this is where you can think about those divisibility rules. 9 plus 3 is 12. 12 is divisible by 3, or if you want to break it down further, 1 plus 2 is 3, so 3 plus 9 is 12, 1 plus 2 is 3, 39 is divisible by 3. 1, 2, 42, 1, 2, 3, 45, 1, 2, 3, 48, 1, 2, 3, 51. Okay, 5 plus 1 is 6. 6 is divisible by 3, so 51 is divisible by 3. 1, 2, 3, 1, 2, 3, 57. 5 plus 7 is 12. 12 is divisible by 3. 2, 3, 60. 1, 2, 3, 63. Okay, 6 plus 3 is 9. 9 is divisible by 3. Okay, So at this point, some of you smarter folks are seeing this little pattern developing. Do you see it? So 21 is divisible by 3, and then you skip down. So 21 plus 30 is 51. So 51 plus 30 is 81. So if you're seeing that pattern, you could kind of move ahead. If you're not seeing it, it's okay. We're just going to keep going like we were. 64, 65, 66. 1, 2, 3, 69. 6 plus 9 is 15. 15 is divisible by 3. 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. There's that 81 we were talking about earlier. 2, 3. 1, 2, 3. 87. 8 plus 7 is 15. 15 divisible by 3. Okay. 93. 9 plus 3 is 12. 12 is divisible by 3. And our last one is 99. Okay. All right, so now I've looked at my 3's. So I don't have to worry about anything being divisible by 6 that I haven't already colored in, because remember the rule for 6 is anything's divisible by 6 if it's also divisible by 2 and 3. And I've colored in all the 2's, the multiples of 2 and all the multiples of 3. Okay. So the next one to consider is 7. Okay. And here I find it's just easier to know my 7's facts. Okay. 7, 14, 21. Okay. 28, 35, 42, 49. 49 is the first one I have to color. It's the first number that is a multiple of 7, but is not a multiple of 2, 3, 4, 5, or 6. Okay. So we got 49, 56, 63, 70. Okay. And the next one I color in is 77. Okay. And then after 77, and I could go back and I could look at my multiplication chart if I wasn't sure, but it's 84. Okay. And then after 84, if I'm not sure, again, I could look at my multiplication chart, or I could just count on 1, 2, 3, 4, 5, 6, 7. So 84, and then 91 is the last one I have to color in. Okay, so and then 98 is already colored. So the only 3 I had to color in for 7's were 49, 77, and 91. So the interesting thing is that I'm actually done at this point. I could think about things that are divisible by 8, but anything that's divisible by 8 is also a multiple of 4. Think about that, because there's 2 4's in every 8. And anything that is a multiple of 9 is also a multiple of 3, because there's 3 3's in a 9. So what I have left here are the first round of prime numbers between 1, which is neither prime nor composite, and 100, which is a composite number.